Hello everyone, you are welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says, a steady, incompressible two-dimensional velocity field is given by the vector v, which is equal to uv, and then that's equal to 0.5 plus 0.8x in brackets multiplying vector I plus 1.5 minus 0.8y in brackets multiplying vector j, where the x and y coordinates are in meters and the magnitude of velocity is in meters per second. A stagnation point is defined as a point in the flow field where the velocity is 0. A. Determine if there are any stagnation points in the flow field, and if so, where. B. Sketch velocity vectors at several locations in the domain between x equals -2 meters to 2 meters and y equals 0 to 5 meters. Qualitatively describe the flow field. So let's look at how you are going to solve this question. So we have been given the vector v, okay, which has components u and v, which is equal to 0.5 plus 0.8x multiplying vector I, okay, plus 1.5, okay, minus 0.8y multiplying vector j. Okay, so this represents the u, which is the x component, and then this represents the v, which is what, the y component. Okay, so the question says that we should determine if there are any stagnation points in the flow, and then if so, we should determine where the stagnation point will be. Okay, and then the question is even telling us that the stagnation point is defined as the point in the flow field where the velocity is 0. Okay, and then this velocity is a vector and then it has components. Okay, so for the velocity to be 0, then the components must be equal to 0. Okay, so at the stagnation point, the component must be equal to 0 in order for the actual velocity to be equal to 0. Okay, so at the stagnation point, you're going to see that the u component will be 0 and then the v component will also be 0. Okay, that's what this means. Now, so we know that there's a stagnation point. Okay, so the question is asking us to find where the stagnation point will be. So to find where the stagnation point will be, you're just going to take the u expression and then the v expression and then equate them to 0 and then solve for the x and y values. And then those values combined will give us the coordinate of the stagnation point. Okay, so to find the x component, you are going to have 0.5 plus 0.8x and then equate it to 0. Okay, then you solve for x, which will give us a value of minus 0.625 meters. Okay, and then for the y also, we are going to have 1.5, okay, minus 0.8y. Okay, and then that will be equal to 0. So when you solve for this also, you are going to get the y component to be equal to 1.875 meters. Okay, so this means that we can locate the stagnation point at x equals minus 0.625 meters and then y equals 1.875 meters. Okay, so now we know that there's a stagnation point and then we can locate it using this coordinate here. Okay, so that's for the part A. So now let's look at the B. The B says that we should sketch velocity vectors at several locations in the domain between x equals -2 to 2 meters and then y equals 0 meters to 5 meters, and then we should qualitatively describe the flow field. So let's look at how you are going to solve this also. Okay, so we've been given a range for the x values and then the y values. Okay, so the x values can be from -2 meters to 2 meters, and then the y values can also be from 0 meters to 5 meters. Okay, all right. So we can pick any values within this range and then use it for the within this domain and then use it for the x and then y values. Okay, so to make this easy, we are just going to consider the whole numbers. Okay, so what I'll do is that I will consider the x values. Okay, let's look at how I'm going to do this. I will consider x values from -2 to 2. So you're going to have -2, -1, 0, 1, and 2. Okay, and then for the y values, I'll now come and consider 0, 0, 0, 0, 0. Okay, so you see the combination that we have. We have when x is -2, we consider y to be 0, x is -1, we consider y to be 0, x is 0, y is 0, x is 1, y is 0, x is 2, y is 0. Then from here, we come and look at another combination also. Okay, so for this also, we are just going to consider x to be -2, -1, 0, 1, and 2 like the previous one. And then this time around, the y value should become 1, 1, 1, 1. Okay, so we're going to do this for all the x and then the y values. Okay, so at the end, we are just going to have a nice combination that we can use to generate the u and then the v components of the velocity. Okay, so if you look at this table here, you see that I have x here, I have y, we have u, and then v. Okay, so you see that for the x values, first of all, I'll consider from -2 to 2, and then the y values I consider 0 first. Okay, do you see it? Let me circle this again. I considered 0 first. Okay, and then afterwards I came to start from -2 again for the x values, and then this time around the y values were just 1. Okay, do you see it? So you do this till you get to the 5. Okay, which is for the y values. Okay, because the y values are from 0 to what, 5. You can consider any value in this range. Okay, so you see that this is how I used. Okay, this is what I applied for the table. Okay, if you did this way, it will be much more easy for you to graph. Okay, I don't want to consider any decimal values here. Okay, so that's how come I generated the table, and then I generated the table using Excel, which I'm going to show you how I did it at the end of the video. Okay, so basically that's how to get the x and then the y values. Okay, you consider the x values from the -2 to 2, and then the y values should start from 0. Okay, then from that you come and change the y values to 1, you change it to 2, 3, 4, and then 5. Okay, so that'll help you get the combination values for x and y. Okay, so after getting your x and y values, you are just going to use them to calculate for your u and then the v values. Okay, we know that the u is equal to 0.5 plus 0.8 x. Okay, so let's look at the v also. The v is also equal to 1.5 minus 0.8 y. Okay, so what we are going to do is that if you pick an x value, you pick its corresponding y value. Okay, so let's say we are using x is -2 and then y is 0, which is the first point that we have here. Okay, let's look at what you are going to get for the u and then the v. Okay, so if we do this, we are going to have u to be equal to 0.5 plus 0.8 multiplying what, -2. Okay, and then this will give us u to be equal to what, minus what, 1 meters per seconds. Okay, and then this one we're going to have v to be equal to 1.5 minus 0.8, and then you know the y component in this case is 0, so just 0. So you're going to have v to be equal to 1.5 meters per second. Okay, and then if you look at the table, this is u. Okay, this is the u value, and then this is the v value. Okay, please, the values are really appearing small here, so to see them clearly I will advise that you increase the quality of the video or rotate the font. So that's the u and then that's the v. Okay, so after that the next column represents the magnitude. Okay, so we just have to calculate the magnitude of the velocity vector. To do this we are just going to have the square root of -1.1 squared, okay, plus 1.5 squared. Okay, and then this will give us the 1.860108 meters per second that we have there. Okay. All right. So this is how to get the components of the velocity and then the magnitude. Okay. And then to find the angle, you just have to take the tan inverse of the y component over the x component. Okay. So that would be tan inverse of v over u, which will be equal to the tan inverse of 1.5, okay, divided by minus 1.1 in this case. Okay, so let's do this and see what you're going to get. This, when you're doing this, make sure your calculator is set to degrees. Okay, so tan inverse of 1.5 divided by minus 1.1. Okay, so this will give us a value of minus 53.7462 degrees. Okay, like what we have here. Okay, like what we have here. Okay, so I'm going to do the same for all the x and then the y values. Okay, we pick an x and y value combination, you find the u value, and then you find the v value, then calculate for the magnitude, then you find the angle. Okay, using the tan inverse formula. Okay, so you see that this will be very, very tedious if you want to calculate. Okay, because you have a lot of x and y value combinations. Okay, so doing this will take a lot of time. That's why it is advised that you use the excel to generate the values. Okay, okay, so after doing this, then you're going to get this table that I have here. Okay, what I have here is just a continuation of the table. Okay, so this is how to get the table. Okay, so after getting the table, you have to plot the flow field. Okay, so let's look at how you are going to do this. Okay, so to plot the flow field, you must get your graph sheet. I have mine here. Okay, and then you draw the x and then the y axis. This is the y axis and then this is the x axis. Okay, so you just have to draw the graph, and then after doing that, the next thing you're going to do is that you're going to plot the x and y points. Okay, so let's look at what I mean. So for the first point, we have x to be minus 2 and then y to be 0. Okay, this is what I'm reading. We have x to be minus 2 and then y to be 0. Okay, so I'll just come to the graph and locate minus 2, 0, which will be this point here. Okay, do you see it? And then the next one, we have x to be minus 1 and then y to be what? 0. So that will be this point here. So that will be minus 1, 0. Okay, and the next one we have 0, 0, which will be just this point here. And then the next one is 1, 0, which will be here. And then we have 2, 0. Okay, and then the next one is going to be minus 2, 1. Okay, and then we are going to have minus 1, 1. Minus 1, 1 will be here. Okay, and then we are going to have 0, 0 here. Okay, and then we are going to have 1, 1, and then 2, 1. Okay, here. Okay, and then from there we are going to have minus 2, 2, minus 1, 2, and then 0, minus 2. Okay, and then we have 1, 2, and then 2, 2 here. Okay, and then the next one is going to be minus 2, 3. Okay, and then minus 1, 3, and then 0, 3. Okay, okay, and then we are going to have 1, 3, and then 2, 3. Okay, and then the next one you're going to have minus 2, 4. Okay, minus 2, 4, minus 1, 4, 0, 4, 1, 4, and then 2, 4. Okay, and then the next one is going to be minus 2, 5, minus 1, 5, 0, 5, 1, 5, and then 2, 5. Okay, so that's the plot for the point. Okay, so first of all you plot the coordinates for the x and then the. Okay, so after plotting the points, what you're going to do is that you are going to plot the velocity vectors. Okay, so let's look at how you are going to do this. So first of all, let's consider the first point, which is x equals minus 2 and then y equals what, 0. Okay, considering this point, our u is minus 1.1 and then the v is 1.5. Okay, and then we have the magnitude to be 1.860108 meters per second. Okay, meters per second. And then we have the angle to be equal to minus 53.746 degrees. Okay, so let's look at how you are going to be doing the plot. Okay, so to do the plot, we are just going to consider the single point that we plotted. Okay, so we plotted minus 2, minus 2, 0. Okay, this is what we plotted. Okay, so let me show you. So this minus 2, 0 that you plotted here, okay, that's what I have brought here. Okay, let's take note of that. Okay, I want to treat them individually so that we understand how to do the plot. So that's our minus 2, 0. Okay, and then on the graph you see that we have this axis here. Okay, we have the x and then the y axis on that particular point. Okay, so we're just going to do the same thing on the points we have brought out. Okay, so we're just going to have this here. Okay, let's take note of this. Okay, so just like we have here. Okay, okay, so let's look at what you are going to do. So to make the plot, what you're going to do is that you consider the u value and then the v value. Okay, you consider their signs. Okay, so in this case you see that the u value is negative and then the v value is what? Positive. Okay, so let's go what you're going to do. So for this quadrant, x is positive, y is positive. Then for this quadrant, x is negative, y is positive. And then here x is negative, y is negative, and here x is positive, y is what? Negative. Okay, so let's go what you're going to do. So in this case, x is negative and then y is positive, which means that you're going to be in this quadrant here. Okay, so and I'm going to look at how you're going to plot the vector. So to plot the vector, you consider the angle. Okay, you're going to consider the angle now. You see that we have a negative angle here. Okay, so what you do is that we always measure the angle from the x. We measure the angle from what? The x axis. Okay, and then one thing you have to note is that when you're measuring in the clockwise direction, then that means that the angle is negative, and then when you're measuring the counterclockwise, that means the angle is what? Positive. Okay, so in this case the angle is what? Negative. That means that you're going to measure in the clockwise direction. So we know the quadrant that we are in. Okay, which is this quadrant here. Okay, so that means that our vector is going to be in that quadrant. Okay, so we just have to measure the angle and then easy to determine the direction of the vector. Okay, but in this case, measuring minus 53.746 will be very difficult, so we are just going to forge the angle. Okay, if you are using a graphing app, that one you're going to get the accurate angles, but in this case, since you are plotting it manually, you will just have to assume the angles. Okay, so you're just going to assume an angle of what? 53.746 degrees. Okay, so you notice that you're going to be measuring from the x-axis. In this case, since the angle is negative, you're going to be moving in the clockwise direction. Okay, so you're just going to be moving in this direction. Okay, so let's take that to be our 53 degrees. Okay, so after getting this, you are just going to erect the vector. Okay, so this will be the vector. Okay, so the length of the vector represents the magnitude, which is the 1.86 in this case. Okay, so the length will represent the magnitude, and then this angle here, okay, becomes the 53.746 degrees. Okay, so you see that we just assumed the angle. Okay, so that's how to make the plot. So to make the plot, you consider the point first, and then after that you locate the point and then consider the signs for the u and then the v values to determine the quadrant that you are going to be using. Then you consider the angle, whether it is negative or positive, you measure it. Okay, then the length of the arrow will correspond to the magnitude. Okay, so after doing this, you will come to the graph and then you just come and do this for the vector. Okay, just come and draw the vector on the graph. So we're going to have this to be our vector. Okay, just to take an angle of what? 53.174, and then the length should correspond to the magnitude. Okay, so let's take this to be our 53.746. Okay, So you look at it that we are considering 1.86, which is the magnitude to be of what this length that we have chosen here. Okay, so that means that any value less than 1.86 should have an arrow shorter than this one, and then any value more than 1.86 should have an arrow longer than this one. Okay, so you just have to use that assumption to plot your values. Okay, so let's look at the next one. Okay, let's look at the next one. So for the next plot, you're going to use x to be -1 and then y to be 0. Okay, and then doing this, our u will be -0.3, and then the v will be 1.5. Okay, and then the magnitude will be 1.529706 meters per second, and then the angle is -78.69. There are other values there, but it has been covered. Okay, so let's leave it that way. Okay, so we know that on the graph we are actually looking at this point here because we are plotting what -1 and 0, so you're looking at that point here. Okay, so this also we are just going to have this cross here, okay, which is the axis. Okay, and then I will just bring that out. Okay, I'll just bring that out, and then we have this here. Okay, so you see that the x value is, the u value is negative, and then the v value is what, positive, which means that you are going to be in this quadrant here. Okay, and then we know the angle to be what, -78.69, which means that you are going to be measuring in the clockwise direction. So we are just going to assume the angle. So let's take this to be, okay, I'm actually erasing it. Okay, so let's take this to be our 78.69. Okay, and then the magnitude is 1.52, so that means it has to be shorter than the previous one. Okay, so let's reduce it. Okay, at this point, let me just make it any length. Okay, so let's assume that to be our 1.529. Okay, and then our angle, and then this will be our angle. Okay, which is the 78.69. So you see that because the angle is negative, we moved in the clockwise direction. Okay, so on the graph itself, okay, on the graph itself, you just come and assume it here, but you see that the first one had a magnitude of what, 1.86, and then this one is having a magnitude of what, 1.529. So that means that this one must be shorter than the previous one. Okay, but the angle it makes with the x-axis is bigger than the previous one, so you just have to make sure that its angle is bigger than the previous one. Okay, so we're just going to have something like this. Okay, so you're going to do the same for the next one too. Okay, I can't plot all of them, so I'm just going to plot few of them and then you do the rest. Okay, so I'll just show you how the graph will look at the end. Okay, so let's consider the next point. Okay, in this case I'm just going to consider one that you're going to have a positive angle, so that we look at how the plot will be. Okay, so for this one I need a positive angle, so let's consider x to be 0 and then y to be 0. Okay, if you do this, you're going to have the u to be 0.5, and then the v to be 1.5, and then the magnitude will be 1.581 meters per second, and then the angle will be 71.56. Okay, so what we do is that on the graph, we are just going to locate the plot of what, 0, 0, okay, which will be what we have here. That's what, 0, 0, okay. So with the 0, 0, 2, we're just going to, you don't necessarily have to bring this axis that I'm bringing here. Okay, you don't necessarily have to bring it. Okay, so let's bring the 0, 0 out. Okay, this is the plot of 0, 0. Then we have the axis. Okay, this axis, you don't have to indicate it on the graph because the lines are already indicating it. Okay, so that's our 0, 0. Okay, so now let's consider the u value. You see that in this case the u value is positive and then the v value is also positive. That means that we are going to be in this quadrant. Okay, all right, and then the angle too is positive. That means that you are going to be measuring the angle from the x axis but in the counterclockwise direction. Okay, So let's look at that. We have an angle of 71.56, so that's going to be somewhere here, 71.56, and then the length of the arrow represents the magnitude. Okay, so at the end we are measuring the angle in the counterclockwise direction, so we are just going to move in this direction. Okay, so this angle here becomes the 71.56. So you see that if the angle is positive, you move in the counterclockwise direction, and then if it is negative, you move in the clockwise direction, and then we measure the angle from the x-axis always. Okay, let's take note of this. Okay, so in doing this, when you go to the graph, our plot is going to be here. Okay, our plot is going to be somewhere here. Okay, so that's what you're going to do for all the points. Okay, that's what you're going to do for all the points. So let me do one more. Okay, let me do one more for you. Okay, so let me free up some space. Let me take another positive plot. Okay, let's look at that. Let's consider another positive angle plot. So for that one, let's consider x to be 1 and then y to be what? 0. Okay, if you do this, you are going to have the u value to be 1.3, and then the v to be what? 1.5. Okay, and then the magnitude will be 1.9849 meters per second, and then the angle is 49.085 degrees. Okay, so we are plotting 1 0, right? We are plotting 1 0. So okay, so we are going to have our plot to be here. Okay, this is 1 0. Okay, this is 1 0. So you just draw that as is here. Okay, you don't have to do this as is when you are plotting. Okay, I'm just doing this so that you will understand it. So this is our point 1 0. Okay, and then this is that as that are indicated there. Okay, and then because the u value is positive and then the v value is positive, we're going to be in this quadrant, which is the first quadrant. Okay, and then our angle is what? 49.08085, and then that's a positive angle, so you're going to be measuring in the counterclockwise direction. Okay, so let's consider this to be our 49 degrees. Okay, and then the length represents the magnitude. Okay, all right, so let's look at that. So our angle is 49, then you're moving in the counterclockwise direction. Okay, so that will be the 49.08 degrees. Okay, so you will come to the graph and then you come and look at it. So this one, the magnitude is 1.98. The previous one was 1.58, so that means that this one has to be longer than the previous one. Okay, so let's see that something like this. Let's say something like this. Okay, so this is how to do it. Okay, so you see that you are just assuming the plot is not really drawn to scale because you are doing it manually. Okay, because you want to do it to be exactly correct, it is going to take a lot of time. Okay, so you see that you're actually assuming it. So if maybe, okay, so let's say we have a magnitude of 1.5. Okay, and then we represent it with this length. Okay, and then we have another magnitude of what? 3, and then we want to represent it. You know that that will have to be the double of what we have. Okay, so that would be something like this. Okay, you see that would be something like this. Okay, so you just have to know how you do the assumption. Okay, so let's say you have another magnitude of 1, and then you have another which is 2. You know that that will have to be a double of the previous one, unless we have 1.8, and then we know that what? 1.7 will be what? A little shorter than this. Same for the angles also. Okay, so let's say I have an angle of 45 degrees. Okay, 45 degrees, and then I measure it as this. Okay, then this is 45. Okay, and then I have another which is 50 degrees. You know that that will have to point a little higher than the 45. Okay, so that's how we do it. Okay, you just have to, yeah, you just have to make sure that it makes sense. Okay, you just have to make sure that it makes sense. So that's how to do it. Okay, guys, so at the end, this is how the graph will look like. Okay, this is what you are going to have And then the red dot that I have there represents the stagnation points. Okay, I was able to plot that using the coordinate that we calculated for, which is the x equals minus 0.625 meters, and then the y equals the 1.875 meters. Okay, so that gives us the stagnation point. Okay, so let's look at the behavior of the flow. Okay, so looking at this flow, it actually looks like this. Okay, we have something like this. This is how the flow looks like. Okay, we have something like this. Okay, this is how the flow looks like. So to describe the flow, we are going to say that the flow enters from the top and then the bottom. Okay, and then spreads to the left and then the right side. Okay, around the horizontal line. Okay, around the horizontal line that passes through the stagnation point. Okay, you know that we have this stagnation point here, and then there's going to be a horizontal line passing through this stagnation point. Okay, so what will happen is that the flow will enter from the top and then the bottom, and okay, and then spread to the left and then right. Okay, around this horizontal line that passes through the stagnation point. Okay, so that would be the description of the flow. Okay guys, let's look at how you are going to generate the table using Excel. Okay, so let's look at that. So I'll first of all enter my X value here. Okay, and this should be Y. Then let's have our U, and then our V here. Okay, and then this should be the magnitude. Okay, and then let's have the angle here. Okay, so for the X values, you are going to start from -2, and then go to -1, then go to 0, 1, and then 2. Okay, so what I'll do is that I'll just copy these values. Okay, just press Ctrl C and then copy it, and then go to the next cell and then paste it there. Okay, and then go to the next one, paste, and then go to the next one and then paste, go to the next one and then paste, and then let me see, one, okay, let me paste one more, then paste. Okay, then from here you go to the next cell. Okay, and then our y values, you are going to start from 0. Okay, so let's enter 0. Then you move your mouse to the far right end of the cell, then you move it to 2. Okay, then you're going to have zeros throughout. Then the next value is going to be 1. So let's enter 1, then move it all the way to 2. The next one is going to be 2. Then let's move it all the way to 2. And then the next one will be 3. So just move it to 2. And then the next one will be 4. So we move it to 2 again. The next one will be 5. So we move it to 2 again. Okay, so that's what we have now. So now let's look at how you're going to calculate for the U and then the V. Okay, so we have the formula for U to be, you have 0.5, okay, plus 0.8, okay, multiplying what? X. Okay, so I just come and choose X, okay, and then close the bracket and then press enter. Okay, that's what I'm going to have. Now click on it and then put my mouse at the far right corner and then drag it down for all the values. Okay, then all the U values will be calculated. So I'm going to do the same for the V also. So equal to bracket open, we have 1.5 minus 0.8 multiplying what? Y. Okay, so let's just click on Y and then close the bracket and then press enter. Then we have our 1.5. So we click on the far right corner, we drag it down for all the values, then we generate our values. Okay, this is what we have. So now let's look at how you are going to calculate for the magnitude. Okay, so to calculate the magnitude, let's write the formula. We're going to use equal to, then write SQRT, which represents square root, then bring brackets. Okay, then after the bracket, I will click on the u value. Okay, and then raise it to the power, bracket open, 2 bracket close. Okay, then plus, then now I will come and click on the v value. Okay, and then raise it to the power, bracket open, 2 bracket close. Okay, then I now close the bracket. Okay, so this is the formula. Okay, because the square root is, we are going to find the magnitude. We are just going to square the values and then we take square root of it. Okay, so just press enter at the end, then you have your value. Then just click on the far right corner. Okay, then you drag it down. Okay, so this is what you have. So now let's look at how you're going to calculate the angle. So to calculate for the angle, if you do a tan inverse of the v value over the u value straightforward, you're just going to get your answer in radians. Okay, but you want our answer in what? Degrees. Okay, so let's look at how you're going to write the formula. So you're going to write equal to, then you write degrees. Okay, degrees. Okay, degrees, then you bring bracket. Okay, then we write the tan inverse. Tan inverse in this case is a tan. Okay, so tan inverse, then you bring bracket. Okay, then you are going to have the v value, okay, divided by the u value. Okay, then you close the bracket. Okay, then let's close the first bracket also. Okay, then you press enter. So you're going to have your angle, then you drag this down. Okay, you drag this down so that you calculate the angles for all the values. Okay, so that will be the angle. So this is how to generate your table. Okay, so from here, then you will use the table for your plot. Okay, to see how the points will be plotted. Okay, to see how the points will be plotted, you can just select this. Okay, to see how the x and the y values will be plotted, you can just select this. Okay, and then when you select that, you go to insert. Okay, then you go to the graph section. Okay, then you click on the charts. Okay, the chart section, and you go to the scatter plot side, then we click on the first scatter plot option that you will see. You're going to have this. Okay, so this is actually the plot for the x and y value combinations. Okay, so this is what you are going to use to plot the vectors. Okay, like we did in the manual plotting. Okay, so that's all for this lesson. Thank you very much for watching. Please make sure you like the video and subscribe to the channel.